Hello everyone, welcome back to my channel. My name is Adam and I'm from Morocco. Today I've got another maths problem for you that reads as follows. Let A, B, X and Y be non-zero real numbers. Prove that if AX plus BY were equal to 1, then the fraction 1 over x squared plus y squared would be smaller than the number a squared plus b squared. As usual, please feel free to give this problem a try, and then when you are ready, keep watching this video to learn the answer. Okay. So the way we are going to solve this problem is that we are going to assume the first part and then prove the second part. So if we assume that the first part is true, ax plus by equals 1, if we assume this is true, we have to prove this inequality. And the best way to prove any inequality is through calculating the difference between its two sides. So for example, here I have to prove that this number is bigger than this number. So I can calculate 1 over x squared plus y squared minus a squared plus b squared in brackets, or the other way around. I prefer to calculate this number minus that so that it gives me a positive number, because positive numbers are generally a bit easier to work with than negative numbers. So now I'm going to calculate the difference between these two numbers. The first step to do that is to make both numbers have a common denominator, which will be x squared plus y squared. So I'm going to put a fraction line with the denominator being x squared plus y squared. So when I make x squared plus y squared the common denominator, this minus 1, which I can think of as plus a minus 1 over here, this minus 1 here can stay intact. I have done nothing to it. Whereas this number a squared plus b squared is going to be multiplied by x squared plus y squared. So if I get that, so I have to multiply by x squared plus y squared to make it into a common denominator. Now the next logical step is to expand these brackets to multiply these numbers into each other. So I'm going to put an equal sign, a fraction line, and I will do just that. So a squared multiplied by x squared plus b squared multiplied by x squared plus a squared multiplied by y squared plus b squared multiplied by y squared minus 1 over the common denominator, which is x squared plus y squared. Now a little trick to verify if this expansion is correct is, before you do any simplifications or anything, count the number of terms that you get and compare it with the product of the numbers of terms within each bracket. So here I have 2 terms and here I have 2. 2 times 2 is 4. So when I expand this product, I am supposed to get 4 different numbers. This is before any simplification or cancelling or anything of that sort. That's a way to tell if you have made a mistake, because if you do not find the 2 numbers being the same, then you may have forgotten a term when you were doing your expansion. So now that I have expanded these brackets, I do not see a straightforward method to keep forward with these calculations. I'm a little bit stuck. So I have to find a way to simplify this numerator. Now I can go back to my assumption. We assumed at the beginning that ax plus by equals 1. If we compare this expression with this one, we can see a few similarities, because a squared x squared is nothing but ax all squared. So a squared x squared is nothing but ax all squared. And similarly, b squared y squared is the same as by all squared. So b squared y squared is equal to the number by all squared. So maybe if I could take this expression and square both sides, I will find something that will allow me to proceed further with this fraction. So let's just do that. So if I take the right hand side first, 1 squared is equal to 1. There's nothing there. Now for the left hand side, I will have ax plus by all squared. What is that equal to? Well, it is equal to the square of the first term, which is a squared x squared, plus the square of the second term, b squared y squared, plus 2 times the product of these two terms. So 2 times ax times by. So now I could rearrange these terms into a squared x squared plus this term. I could rewrite this. Since multiplication is commutative, I could change the positions of these different factors. So I could write this, for example, as a bxy. I could write it as a ybx plus the final term, b squared y squared. So now I have found an expression to put instead of this number 1. I could substitute this one with this expression. So I will just rewrite this sum, a squared x squared plus b squared x squared plus a squared y squared plus b squared y squared, and then instead of putting a minus 1, I will instead put in a minus bracket this expression, a squared x squared plus 2abxy plus b squared y squared. So now I could distribute this minus sign over the terms in these brackets and see which terms cancel each other out. So I've got my first 4 terms, and then I'm going to add minus each of these terms. So minus a squared x squared minus 2abxy minus b squared y squared. All of this is over x squared plus y squared, of course. So now there are some terms that cancel each other out that I could simplify. This a squared x squared and this minus a squared x squared add up to 0. So I could just cancel them. Similarly, I could cancel the b squared y squared and the minus b squared y squared. So now I have greatly reduced the expression that I had in the beginning. Now, once again, what can I do next? Again, I will have to look for some pattern. Here, just like previously, I have these 2 terms, a squared y squared, which is again the same as ay all squared, and b squared x squared, which is bx all squared. So maybe I could use the same formula as here. If I take ay plus bx all squared, I will get a squared y squared plus b squared x squared, the square of each of these terms, of course, plus 2 times this number, ay, times this other number, bx. So then I could of course always arrange these terms to give me a squared y squared plus 2abxy plus b squared x squared. Now if I look at my numerator, I have something which is quite similar to this, with just one difference, which is that there is a minus sign next to this term as opposed to a plus sign. So maybe I should consider instead the expression ay minus bx all squared. So if I now have a look at ay minus bx all squared, it is going to give me the same expression as this one, just with a minus sign here instead of a plus sign. So it will be a squared y squared minus 2abxy plus b squared y squared, which is exactly what I have in the numerator. Here is this term, here is this term, and here is this term. There are no other terms because they have all cancelled out. So I could actually say that this numerator is equal to ay minus bx all squared over x squared plus y squared. So now that I have managed to turn this difference into this expression, it has actually become quite easy to work with it. Since x squared is a positive number, every square is positive. Y squared is also positive. The sum of two positive numbers is positive. In fact, they are strictly positive numbers because x and y are non-zero. Otherwise, we would have a 0 in the denominator. This number, whatever it is, it's also positive because it is a square. So I will say, since x squared plus y squared is positive, because each of these is positive, and the numerator ay minus bx all squared is also positive, given that it is, well, a square, well, this one is just positive, not strictly, then the ratio of two positive numbers cannot be anything but positive, which means that this ratio is indeed positive. But this ratio is equal to the difference of these two numbers. So what we have then is a squared plus b squared minus 1 over x squared plus y squared is positive. Therefore, a squared plus b squared is bigger than 1 over x squared plus y squared, or the other way around, 1 over x squared plus y squared is smaller than a squared plus b squared. So we have proven that this inequality is true, assuming that this equality is true. So the proof is done, and we can write QEG. Right guys, thank you so much for watching. If this video has taught you anything, or if it was just entertaining, then feel free to give it a like. Also subscribe to my channel if you want to watch more videos like it. And until next time, see you.